Welcome back, students. This is the session number 13 of NEET Physics, and the chapter under consideration is the laws of motion. So this is session number 13 of this chapter, and we will be solving two questions in this session, which were asked in the previous NEET or the CBSE this pre-medical test examinations. So this question I have taken from one of these NEET papers, and the question is: a person of mass 60 kg is inside a lift of mass 940 kg. Now he presses the button on the control panel and the lift starts moving upward with an acceleration of 1 meter per second square. If G is equal to 10 meter per second square, then the tension in the supporting cable or the cable of this lift is, ये चार options दिए हुए हैं. The question again here, it is very easy. इसमें कुछ नहीं है. आप एक ये मैं इसको I will just try to explain this question with the help of this diagram. ये आप मान लीजिए this is the lift of the cable and this is the supporting cable. ठीक है, ये इसकी cable है. Now the weight of this lift, इसके अंदर a person is standing whose mass is 60 kg. So the total mass कितना हो जाएगा? The total mass of the lift, total mass of the lift plus passenger, ये हो जाता है आपका 1000 kg. That is 940 plus 60. 940 plus 60 is equal to 1000 kg. So the weight that will be now the weight will be acting in the downward direction. So it will be, since G is equal to 10, so the weight will be equal to weight is equal to 1000 into 10, which is equal to 10,000 Newton. So 10,000 Newton is the magnitude of the force which is acting in the downward direction. Now, if the acceleration is since the lift is moving in the upward direction, therefore the acceleration will be in the upward direction. Let us say it is A. This is the cable of this lift, and the tension will be in this direction. ठीक है, tension in this direction क्यों होगा? Because the tension always acts, first thing is it always acts away from the body. ठीक है, and secondly this lift is moving upward with an acceleration of A. तो ये ऊपर तभी move करेगी when tension is more than the weight of this lift. So net force इसके ऊपर क्या हो जाएगा? Net force on the lift, net force in the upward direction. वो कितना हो जाएगा? That will be equal to T is the tension in the cable of this lift, and the weight is acting downward, which is equal to 10,000 Newton, and this will be equal to the mass of this lift into the net acceleration. The mass of the lift into the acceleration of this lift. तो ये कितना हो जाएगा? It implies that T minus 10,000 is equal to mass of the lift is equal to 1000, and the acceleration is what? It is equal to 1 meter per second square. So the tension in the supporting cable or the cable of this lift will be equal to 1000 plus 10,000, which is equal to 11,000 newtons. ठीक है, तो यहाँ पर चार ऑप्शन दिए हुए हैं आपके पास में. So the correct option is B, which is 11,000 newton. ठीक है. So again, कोई भी ऑब्जेक्ट ऊपर जाता है या नीचे जाता है, ऊपर कब जाएगा? When the forces which are acting in the upward direction are more than the forces which are acting in the downward direction. और कोई ऑब्जेक्ट नीचे जा रही है तो वो तभी जाएगी when the forces acting in the downward direction is more than the forces which are acting in the upward direction. ठीक है ना. सो तब वो जो है ऑब्जेक्ट नीचे जाएगा. तो इन्हीं कॉन्सेप्ट्स को लेके हम जो है इन क्वेश्चंस को कर सकते हैं. ठीक है. इन दिस केस द लिफ्ट इज मूविंग अपवर्ड, दैट इज द net force in the upward direction is more than the net force which is acting in the downward direction. So the lift will move upward, and since it is moving with an acceleration of 1 meter per second square, so ये हमारी इक्वेशन बन गई थी. दैट इज नेट फोर्स ऑन दिस लिफ्ट इज इक्वल टू टी माइनस दिस mg. दिस इज द वेट. ठीक है. वेट है, वेट विच इज इक्वल टू m इंटू जी होता है. तो उससे जो है ये हमने निकाला था फॉर्मूला. तो सिंस टेंशन इज मोर देन द वेट, सो द लिफ्ट विल स्टार्ट मूविंग इन द अपवर्ड डायरेक्शन. और वही हमने नेट फोर्स की वैल्यू निकाली, टी माइनस 10,000 विच इज इक्वल टू, ये मास ऑफ द लिफ्ट इज इक्वल टू 1000. दैट इज द टोटल मास ऑफ द लिफ्ट, the mass of the lift plus the mass of the passenger into the acceleration. So in this way we have calculated the tension in the cable of the lift, which is equal to 11,000. So the correct option is B. Now this ये जो क्वेश्चन है आपका, ये आपके नीट के एग्जाम में पूछा गया था. एंड I think this question was asked, no, it was not asked in the NEET examination, it was asked in the CBSE All India Pre-Medical Test in 2011. ठीक है. Now I am going to take one again, another question which was asked in the CBSE this All India Pre-Medical Test in the year 2014. So in this question they have given us a force time graph. It is like this. ये 0 है पॉइंट, 2, 4, 6, 8, 6 and 8. And this is the time in seconds. This is 2, 4, 6 and 8. And यहाँ पे आपका फोर्स है, ये आपका 0 हो गया. फिर यहाँ पे दिया हुआ है आपका 3 and then it is given 6. यहाँ पे ये 3, ये आपका 3 है, ये 6 है. And this is the force in Newton. ये फोर्स है आपका and it is in Newtons. और यहाँ पे एक और दिया हुआ है -3. ठीक है. सो और इसके बाद में ग्राफ दिया हुआ है. ये so this is 2 seconds and this is 4 seconds. ठीक है. Now so this force time graph, you can say this FT graph shows the shows the force F, shows the force acting on a particle of mass m the change so this force time graph is showing the force acting on a particle of mass m. The change in momentum of the particle, the change in the momentum of the particle is, there are 4 options here, 24 Newton second, 20, C is 12 Newton second, and the fourth is 6 Newton second. ठीक है, ये आपको दिया हुआ है, ये 4 ऑप्शन दिए हुए हैं, इसमें देखो एक ऑप्शन सही है और वो हमें निकालना है। तो ये क्वेश्चन है बहुत आसान, इसमें कुछ इट्स अ वेरी इजी क्वेश्चन। सी द चेंज इन द मोमेंटम हमें निकालना ऑफ अ पार्टिकल फ्रॉम 0 to 8 सेकेंड, 0 to 8 seconds, वो हमें निकालना है फ्रॉम 0 to 8 सेकेंड। सो द चेंज इन द मोमेंटम in the force time graph is given by the area enclosed by this graph. That is, ये जो आपका force time graph है, इस ग्राफ में जो आपका the area enclosed by this force time graph will give you the value of the change in the momentum. तो ये हम इसको निकाल सकते हैं कि what now the area of this triangle, let us say I am just denoting it by the point, this is the point A, let us say this is the point B, this is the point C, this is the point D, ये E हो गया और ये F हो गया. So now we have to find the area of this triangle, that is AOB. Then we have to find the the triangle of this ABCDEF. इसको GH कर देते हैं. So we have to now find the area of this rectangle, that is BCGH, and we have to find the area of this rectangle, that is DEFC. So the change in the momentum, ऐसे लिखेंगे यहाँ पर, change in momentum is equal to the area enclosed by this force time graph. ठीक है, ये हो जाएगा. Now so ये आपका हो जाएगा, the area of this triangle कितना हो जाएगा, half into base is 2, this is यहाँ से यहाँ तक ये 2 seconds है, and this height, that is AB is how much, 6. ठीक है, तो ये हो जाएगा हाफ इंटू बेस इंटू हाइट, दैट इज हाफ इंटू 2 इंटू 6 हो गया. अच्छा, यहाँ पे क्या हो जाएगा, यू नो दैट मोमेंटम इज अ वेक्टर क्वांटिटी है. सो यहाँ पर क्या है, यहाँ पर जो फोर्स दिखाया जाएगा दैट इज गिवन एज -3 न्यूटन. ठीक है, तो इसका मतलब क्या हुआ है कि वी विल बी हियर राइटिंग इज दैट एज प्लस हाफ इंटू ये हो जाएगा, सॉरी नॉट हाफ, दिस इज अ रेक्टेंगल, सो दैट विल बी इक्वल टू, नाउ दिस इज इक्वल टू 3 एंड दिस इज इक्वल टू 2, तो दैट इज इक्वल टू, ये हो जाएगा, लेकिन आपका इसको प्लस लिखेंगे, लेकिन -3 इंटू 2 प्लस इसका एरिया दैट इज ऑफ दिस रेक्टेंगल, दैट इज DEFC, ये हो जाएगा आपका, दिस इज इक्वल टू 3 एंड दिस इज इक्वल टू 8 minus 4, 4, तो 4 into 3. ठीक है, तो ये हो जाएगा, ये कैंसिल हो जाएगा, 6 हो गया, ये हो गया -6 हो गया एंड प्लस 12. सो द आंसर विल बी इक्वल टू 12 न्यूटन सेकेंड्स. ठीक है, तो आंसर हमारा ये आ जाएगा. सो द करेक्ट ऑप्शन इज द ऑप्शन सी, दैट इज 12 न्यूटन सेकेंड्स. ठीक है, सो इसमें जो सबसे दिस क्वेश्चन इज वेरी इजी. यहाँ पर क्या है कि जो चेंज इन मोमेंटम इज गिवन बाय द एरिया एनक्लोज्ड बाय द फोर्स टाइम ग्राफ, वो उसी कॉन्सेप्ट को यूज करके आई हैव कैलकुलेटेड दिस वैल्यू. So these were the 2 questions which I wanted to discuss in this session 13. In this session I will be taking one more session, that is from this same chapter, that is laws of motion, and thereafter I will be moving on to the next chapter of work, power and energy. So thank you very much for joining in this session, and I hope you have understood both these questions very well, and in case of any queries you can definitely contact me at any moment of time. So thank you very much. Have a nice day. Bye.